Welcome once again to Igcse Chemistry Video Notebooks. This is a continuation of the Unit 6 of Cambridge Igcse Chemistry, Rate of Reaction. Today we'll be looking at another factor affecting the rate of chemical reaction, which is the surface area of solid. Change in surface area of solid. For illustration purpose, we have three different solids here: solid 1, solid 2, and solid 3. Solid 1 has very large particles. Solid 2, the particles have been cut into pieces. And in solid 3, the particles have further been cut into smaller pieces. Solid 1 has small surface area in contact, while solid 2 has more surface area larger than solid 1. Solid 3 has a very large surface area. Large particle equals small surface area, while small particles equals large surface area. Just like the cube here, the cube has 6 surfaces in contact with other reactants like acid or water. The second cube has small particles because the cube was cut into 9 different pieces. And so this has increased the surface area. And this 9 piece of the cube, a single piece has 6 surface area in contact with other reactants. And so 9 multiplied by 6 will give 54 surfaces in contact with other reactants. So this means that the surface area of the cube has increased. This process will eventually cause this cube to react better with other reactants in a particular chemical reaction. Question time. Study the various sizes of calcium carbonate here: calcium carbonate block, calcium carbonate lumps, calcium carbonate powder. Which of the sizes will have a higher rate of reaction with 0.1 mole per dm cube of acid, and why? Pause this video and describe how these various sizes of calcium carbonate affect the rate of chemical reaction. In answering the question, we look at the reaction of acid with calcium carbonate lump and the calcium carbonate powder. The diagram in the first box represents the reaction of acid with calcium carbonate lump. The second box represents the reaction of acid with calcium carbonate powder. In the first box, we have a large lump of calcium carbonate, and we see the particles of acid represented in red. We have less effective collision because the surface area of calcium carbonate lump is extremely low. At the second box, reaction of acid with powdered calcium carbonate, we have more effective collision because the surface area has been increased. Increase in surface area leads to increase in frequency of collision, and this brings about increase in the chance of having effective collision, and which eventually results into increase in the rate of chemical reaction. And so in the box 1, the rate of reaction is low in the box 1, while the rate of reaction in box 2 is high due to increase in the surface area of calcium carbonate from calcium carbonate lump to calcium carbonate powder. Decreasing the particle size brings about an increase in the surface area of the reactant. As the surface area increases, more reactant particles are exposed for collision, and so the chance of having more successful collision increases. This results in an increased rate of reaction.